Okay, for number 4 it says, what are the x-intercepts of the graph? I'm just going to graph the equation and then locate the x-intercepts from there. That's what I would recommend that you do. We start with a vertex. We use these numbers inside the parentheses and at the back of the parentheses behind it to find the vertex. This tells me that my vertex is at -2, comma, +2. -2, comma, +2 is in quadrant 2 on the graph. For the rest of my points, I could make a table of values, but what most of us have been doing this year is practicing working with a rate. We know that for a quadratic graph, the rate we work with is 1 over 1, 3 over 1, 5 over 1. That rate comes from the fact that 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. And if you go up 1 for each of those values that are being squared, on the right side, the y values are changing by 1, 3, and 5. So that's where that pattern comes from. Now, that pattern works, but if we have a coefficient, then those values are being multiplied by the coefficient. So in this case, we have a coefficient of -0.5. So we're going to multiply each of those by -0.5, and this becomes -0.5 over 1, -1.5 over 1, sorry, 3.5 over 1, and -5.5 over 1, or -1/2, -3.5, -5.5. I think I did those math calculations wrong, so let's slow down a bit here. So 3 times 0.5 is -1.5, and 5 times -0.5 is -2.5. That looks better. So from my vertex, I'm going to go over 1 and down 1/2. You can estimate. Then from there, I'm going to go over 1 and down 1.5, finding my x-intercepts. From there, I'm going to go over 1 down 2.5. And I can keep that pattern going. From there, I could go over 1 down 3.5. Missed a tiny bit when I drew it. But anyway, my x-intercepts are going to be 0, 0, and -4, 0. We can double check that because there's a negative in front of the 0.5. It's a reflective graph. It's a little bit wider than the parent function y equals x squared. And that's number 4.